Hello, everyone. We decided that we will wait 5 more minutes for other people to join the channel, so we will start in 5 minutes. Okay, let's get started. Hello, everyone. So welcome to the first meetup under Infrastructure as Code User Group. And this is first time we do it live. And if something goes wrong, please forgive us for that. Today we're going to talk about what's going on the field of ARM templates. And we're going to have 2 sessions. One introduction to Farmer will be done by me, and then David will talk about stepping up the game with ARM templates. A couple of words about the user group. So Infrastructure as Code User Group Oslo was created in 2019, started by me. And the reason I started it was mainly because there were no user group about infrastructure in Oslo, and I decided to start it. And basically, this is the arena where we can talk about infrastructure, immutable infrastructure, infrastructure as code, everything that related to infrastructure, including on-prem, on Azure, on Amazon, if you want to. And so I started it, but it doesn't mean that only me who can talk here. So if you have any idea, or if you have any anyone, if you know somebody who has some interesting ideas to talk about, please contact us, and we will be happy to give you a possibility to talk. So Enso, that's a company where I'm working in, is a kind of a sponsor because it helped me to run this user group. In 2020, so the main focus for me was on workshops. So I did 2 workshops about ARM templates, 01 introduction, and then more advanced how to use ARM templates to implement immutable infrastructure, and then 1 workshop about Pulumi introduction. So, and next week it will be a 2nd workshop about Pulumi, and also I have plans to do Terraform introduction and Terraform implementing immutable infrastructure on Azure with Terraform, 2 more. And as I said, if you have more ideas about infrastructure, please contact me and we can arrange another meetup. Some practicalities about today's workshop. So it's on YouTube, and yesterday I noticed that sometimes YouTube quality cannot be set automatically. Please make sure that you have 720p, so then you will have much better quality of because it will be some demo and some text maybe not in good quality. So when it comes to comments, please write them, or questions, please write them on YouTube comments. And if this for some reason doesn't work, if we, for example, will not manage to answer them, you can write them on a meetup event as a comment, and then we will reply and later after the session. But the idea now is that we will have a session, then Q&A, and then 2nd session. And also Microsoft. So you, like all participants of this workshop, can get this learner badge. So I will post this slide later, or maybe link on the comments. You can register yourself and get the badge. And also the best tech question will get some swag pack from Microsoft. So that's it. So now, David, the scene is yours.
Yes, thank you. Hello, friends. Welcome to this session focused around some advanced and even new capabilities in Azure Resource Manager. My name is David Pazdera, and I work as a cloud solution architect in Microsoft in a customer experience and success unit. A small disclaimer first about my setup. I am running 20H2 Windows 10 version, a VS Code Insiders build. Some of the tools I'm using, like the Bicep CLI and the VS Code extensions, are in alpha phase. Template specs are in private preview. And as Evgeny mentioned, we are piloting this StreamYard service. So, and my session is one big demo. So what could possibly go wrong, right? So I decided to bundle all the topics that were advertised on the meetup group in one connected experience, and tell you a story from a fictitious company that some of you might be familiar with. So welcome to, welcome to Contoso Corporation. I know it's not very innovative, but I was thinking, in case this video goes viral and we have thousands of views, I just didn't want to get into trouble with copyright violation. So Contoso is a safe bet. So a bit background about this company. It's a multinational business, and they recently announced a new business strategy with digital transformation, customer obsession, and lean as a key pillars. So this big change will have a profound impact on IT and internal software development organization, which we'll see. And I will be playing two personas. One will be Matt, a cloud engineer, born and trained as a hardcore IT pro, who was recently promoted to a cloud engineering role. He became part of the central cloud team, focusing on security, compliance, and building a secure and compliant cloud platform that will be used by internal customers like application development teams. So his main focus is the new cloud governance model that the company is really focusing on building, because they have both their internal policies as well as some regulatory requirements coming from the industry. Megan is our second hero, a senior DevOps engineer who's been 5 years with the company. He's part of a team developing a new business service. And when they heard about this new governance model and policies and restrictions, her team is very concerned about that it will slow down their work. So this story will actually be about how these two worlds can work together. We need to, of course, mention the true heroes of our story. So it will be template specs, a new thing that is currently in private preview, but there is a promise that it will come to public preview later this month already. We have deployment scopes, GitHub integration with Azure policies, which is quite a new thing as well. GitHub Actions, of course, to automate a lot of stuff. Bicep as a new transpiler or DSL, and of course VS Code. So I promise no slides, so I'm cheating a bit. These are more like slides, but it's not a PowerPoint. It's everything is happening inside VS Code. Okay, so I just didn't want to complicate stuff, so I'm not running 2 instances of VS Code, but I will always explain what persona I'm playing, so you understand the context. So our story begins with Megan, who actually got an email from IT that these new changes are coming and that they simply need to adopt. So what the central cloud team promised to do is to make sure that those development teams will understand what policies were introduced and they are enforced. And there is actually a new service that's coming from that central cloud team that might help the developers to use compliant infrastructure as code, so they will not sort of hit any blockers in terms of policies that will deny those deployments. So the central cloud team introduced a section on their GitHub page with wikis, so everybody can learn about the policies that were introduced and enforced. So Contoso has 5 policies in place. They are disabling RDP from the internet, enforcing geo-redundant storage in production, enforcing secure transfer on storage accounts, and they are quite picky for what kind of VM images are allowed in the environment. And last but not least, they are prohibiting usage of unmanaged disks. So this all sounds good. So at least now Megan knows what is coming and how she needs to change her resource manager templates to be compliant, but it's still quite a lot of work. So what if there is a better way? She heard that the same team is introducing something called the template library. So she's opening the wiki page to see what is in there. This template library is actually a collection of resource manager templates that are hosted directly in Azure in the centralized services subscription, and it's using the new template specs, which is a capability in Azure Resource Manager that allows to use those artifacts as templates as artifacts stored in a resource group, like any other type of resource that you as a developer or anybody actually can reference in their own templates, maybe as a master template, and then you have linked templates where instead of pointing to some public URI that if you're familiar with linked templates, that's something what you need to have. You will refer to a resource ID pointing to a specific template spec. So that sounds promising. So Megan is trying to see how it looks like. So there is a Contoso template library. At the moment, there is only one specification published, even though my ambition was to create much more. But the UI is that it's like a regular resource group, but you have this new template spec object. And inside that, you can see that it supports some description. So yeah, that's how you can build that library. It does support versioning. So you can imagine that in case you need to change the specification and sort of introduce a breaking change, then you will still have the versions that are like people are using, like version 1. And if in version 2 you're introducing a new change that is going to break the deployments of your customers, it still shouldn't be a problem. And you have the main template, which is something that you actually publish. As you can see, this is a regular deployment template, so there is nothing special about it. I'm using some ARM functions. I will show that template much more in VS Code. The good thing is that template specs also support like a nested or actually linked artifacts. So you can have one main template, but you can also have like a component level resource templates. So it all can be bundled into one template spec. So okay, that sounds interesting. So how can you actually use it in the real life? So if you're familiar with linked templates, if I create a new template, just a basic schema. If I wanted to use a linked template, I would need to linked. Yeah, sometimes it does take a while. This is what I would need to use if I was using regular linked templates. I would need to have a URI that points to a publicly accessible endpoint. So what many people do, they have this like a staging step in their deployment where they upload those templates into a blob storage, and they generate a SaaS token, and they provide this complete URI path to the Azure Resource Manager, so it can actually reach out and use it. But that's that step for staging those templates is quite cumbersome. So this new template specs is actually promising that you won't be needing this anymore. So of course, in a good cooking show, I have something already prepared. So Megan, what she did, she created a template where instead of pointing to a URI, she's pointing to ID. So if we want to zoom out a bit, this is the ID, but of course it's It's not a really doesn't tell you much. We would need to check how it's actually built. So it's a resource ID to an additional or another resource group. So we need to know where the central cloud team actually is storing those template specs. If it's living in a different subscription, which is typically a case, but in my demo environment, I have everything in one subscription. You could also prepend the subscription ID as part of the resource ID function, as you can see from the help. Then the resource type is Microsoft Resources template specs versions, and then in the end you just add the specification template spec name and the way it was sort of deployed to that resource group and the version. So you can in that case you can safely stick to versions that will work. But there is one more thing. Obviously, when we check for now the actual template spec, which is actually part of Matt's story, Matt is using two parameters. One is storage account type, where he's actually only allowing geo-redundant storage. So that's how the template spec will be compliant with those new policies. But then he's using a JSON object to define some configuration instead of having a lot of sort of individual parameters. So what Megan needs to do is actually go back to the wiki and check the template definition. And if we get that page, so it will explain what the spec for the compliance storage is doing, what kind of options you have for storage account type, and what you need to have as a storage account config value in your parameter file. So this is quite important to have. If you don't have this, then obviously your deployment will fail, because ARM is expecting that your storage account config parameter is structured like this. Okay, so that sounds reasonable. I need to switch back here. So what Megan did, she did it. So she is referring to storage account config. She's choosing this prefix, Web West Europe and storage v2. And in the template file, it's it's just the declaration that it's an object. Okay, so that sounds good. And of course, she could try to deploy it. If it works. Before it loads, it's probably good to read the doc into the end. So what the template library enables is it's developer onboarding. So what the central cloud team decided to do is that every developer in Contoso has a visibility to this library. So what I was showing you in the Azure portal, she can actually view that too. And the reader role is actually the only thing that is required for you to refer to this template spec from your code. Okay, so let's see, we have probably first I need to go to the right path, so source, and we have template examples. Yes, and we'll try to deploy. Of course, it worked. No. Not used to working in this kind of resolution. It's thinking. Hopefully it will yeah, so it's kicking a deployment, and we can validate if it's running by going to Megan's resource group where she's building that service one. And we should see that there is an ongoing deployment. Maybe it was already finished. Yeah, so it's this one. Good. So it works as expected. So she's quite happy. But obviously that's not good enough if you want to automate the deployment. So again, the central cloud team is actually introducing an option to onboard your service principals. So what Megan has, going back to VS Code, what Megan has is that she decided to use GitHub Actions, and she created a workflow that will actually deploy this this service one template to her subscription automatically. So we will look into the workflows for service one just to show you the workflow. So right now it's only triggered manually, but or actually no, there is a push from master on this template example path, and there's one job with checkout, log into Azure. So she's using credentials on GitHub to deploy this specific template to a certain subscription using a template parameters, and it's also building a deployment name from the workflow name and run ID. So that's good, but right now I'm cheating a bit because this is a credential that is used by Matt. So how do we actually allow Megan to onboard her service principal so she can actually use that one in her GitHub workflow? So the wiki page says that in order to onboard your service principal, you just need to you have a possibility to fork or not really fork. I won't be forking. I will be just creating a branch of the very same repo, but in reality, Megan's code would be in a different repo than the central cloud team has. So I will create a branch. I will modify one specific parameter file to include a new service principals object ID, which I created maybe using adsp command, and then create a pull request. So it will be reviewed by the central cloud team, and when they push it, they have actually a pipeline or GitHub action or workflow to deploy that change to that environment in Azure. So that sounds promising. Let's try to do that. Just close those. I won't need them now. So create a new branch. Okay, and as is instructed, I should go to the template library IaC, and for production, I should add the new service principal that I created. So I have a cheat sheet over here. Okay, sounds about right. Just to validate, she created some nodes. So yes, she created this service principal called test deploy meg. And no, actually it's called service1sp. And this object ID was returned from Azure AD. So now she actually added it to this array. And she will simply stage that. Commit. And push. One of the many VS6 code extensions that I really like is the one from GitHub, which allows you to actually create pull requests directly in VS Code. So I can actually, okay, the sync is done. I can create a new pull request. I'm targeting master. I can use the last commit message. So it will create a pull request for me. I don't need to leave my IDE. Okay. If I for a second now change my hat and now I'm Matt, I'm the one who is reviewing the pull request. So obviously, in order to protect that main or master branch in that central cloud team repo, you would need to create a branch protection policy. So that's how Megan cannot actually cannot commit to master directly. So yeah, now I'm Matt. I reviewed the change. Trust me, everything looks good. So I will merge. Yes. So that's okay. And I'll switch back to master. So if you have been playing with GitHub Actions, there is actually a very interesting VS Code extension that can show you all the workflows and some settings like secrets. So there is this template library IAM, and I hope that this is the one that actually ran just right now. The good thing is that I can actually get the logs from that run directly in VS Code, which is kind of nice. Not sure if I get much out of that, but it seems that it's green, so that looks promising. So in order to check whether my service principal was added, I just need to go back to the Azure portal and see if the template library first of all, there should be a deployment done today. Yeah, no. Let's check the access control. So I should see three readers, but it's actually just those two. So I need to probably go to the actions and try to trigger it manually. I remember I had some issues with that. So I will run the workflow manually. And when it's started, I can view the logs. Come on. Oh, I think my machine is really busy with streaming, so sorry for a delay. So ideally, I should see everything green. So while it's running, I will show you the code behind that that workflow, which I can actually again see in this view using that VS Code extension. So what I'm doing is check out, log in using the secrets that Matt actually created, giving that service principal permissions to modify RBAC on that resource group, and it's rm deploy action, which is coming from the GitHub Marketplace from Microsoft, which will basically deploy this specific template using the parameters that were actually modified by Megan. So we'll actually look at that template in a moment. So it seems that we got this completed. So if we try to go back and refresh, we should see service 1 SP as a reader. Yes, so actually it's working. Good. And there should be, of course, a deployment. Or in fact, there would be like three deployments. Yeah, I will explain you why there are 3 deployments. So back to VS Code. So the way I build this thingy is that I have this template file. I'll just give you a walkthrough. There are some features that I want to call out. So I'm of course making it very flexible. So it's I have a few parameters: resource group name, location. Service principals is an array, obviously, because if I want people be able to add those additional service principals, I need to have it as array. I always like to have a timestamp and use UTC now function to generate a timestamp for me, which I'll then use as a deployment name. And then for variables, I have role definition ID, which basically is a concat, and I'm referring to a well-known ID for a reader role. And then I have some special variable to distinguish production and QA. I will tell you why. So the main resource is, as you can see at the top, I'm using subscription deployment template. So it is actually, this is an example of deployment scopes. So I'm running a subscription level deployment where I'm creating a resource group. And then I'm doing a resource group level deployment as a deployment. So I'm using that to have both the resource group and all the objects. In this case, it is actually role assignment, which is also can be a deployment. And as you can see, I'm using a copy function So because we have those service principals as an array, so if it's 5, next day it will actually run 5 deployments, 1 for each assignment. And then what is quite important, and it took me a while to figure it out. The role assignment itself, the resource which you need to have in this sort of nested template, it has this principal ID, which is fine, because that's referring to that array member. But the biggest problem was the name, which needs to be a GUID. So the name of that assignment needs to be a GUID and needs to be globally unique. So what I did here was I'm concatenating the service principal ID or object ID that I'm getting from the parameter file, and the variable, because I have actually 2 resource groups, one for QA, one for production, and I'm making a GUID out of it. So in this case, in this way, I can be sure that it will be unique for both resource groups. So yeah, that's an example on how to use deployment scopes, but there are many more. So in the end of the day, it seems that Megan is happy, because now she can actually work on her project, and she will be able to include those template specs as artifacts and use the linked templates method of adding those to her master template. So that was the end of Megan's story. If we switch to Matt, of course, his day started with a message from the CISO saying that, oh, you need to build a number of policies to protect our environment. So they got those defined. So obviously, if you're familiar with Azure policies, you know that you are able to create custom policies. So this is exactly what Matt did. He created custom definitions, and he defined those policies based on the written policy coming from the CISO. So if I switch to custom and I filter on Contoso, you can see that I have those 5 policies that I have on the wiki defined here, and I also assign those policies to the very same subscription, but in the real life you would be assigning them to typically a management group. But there is one new thing I would like to call out, and this is export definitions. So this is a new capability which I'm gonna tell you about. You can read more about that in the Azure Docs, but in essence, what it does, it allows you to take those definitions and assignments as well, and export them to your GitHub repo, and that workflow will actually also create a GitHub workflow that will allow you to automate any changes that you would want to make in those policy definitions and assignments. So in this way, you can actually really treat policies as code and work on the GitHub side and have an automated workflow that will make those changes transparently to Azure. I'm not gonna show you the experience. I believe this is a public preview now, so you can try it yourself. All you need is to sign in with GitHub, or actually I might, if this doesn't kick in, then I will show you the end result. But you just need to sign in to your GitHub account, and it will allow you to choose your repo, your branch. Yeah. So it will allow you to maybe IaC. So I did this one. I choose the repo, my branch, and my directory. Then I can select policies. So add policy definition. So I would, yeah, everything is a bit slow today. I would just search for Contoso. Contoso. It's getting late. I can't type Contoso. So I would choose those that I want to export. I would add them. It will actually ask me if I want to export definition and assignment as well. And then it would do that. So I'm not going to do that again. I will show you the end result. So Matt did it, and in his repo, it looks like this. So we have source and policies. So that workflow created one folder per policy. And in each folder, it actually has a policy JSON, which is the actual policy definition. And it also has the assignment file, which specifies to what scope you want to assign it. And in case you're using parameters, it also gives that policy parameters. So if we have for instance, the VM allowed SKUs, then the policy itself is using parameters for image publisher, offer, SKU IDs, and then in the assignment file, we will have an array with those allowed VM SKUs. Okay, so that's what's created in GitHub in the repo, but it also creates the workflow. So this workflow is again, it's by default it's just created for like a manual triggering, and it's using steps for checkout, login, and then create or update policy. So it's a new action from Microsoft, where you just specify paths with the policies that it should consider, and then you should be able to make changes to those, and then it would update the Azure side. And of course, you need to have the right secret. So if you remember, we had the GitHub action extension. So here you can see that there is this secret that was created by that workflow experience in the Azure portal, and it's giving a very restrictive permission or role to that service principal. It also creates in Azure AD for you. So it is fully automated. It's interesting. I haven't been able to play much more with it, like making some changes, some updates to assignments or even definitions. But at least it's a promising way how you can treat your policies as code and work with them in this kind of fashion. So that was about policy. So that's what Matt did. So the policies are now in Azure, and no one can actually break them. Most of them are deny. So that's quite restrictive. But he also wanted to create that template library for his internal customers. So this part is actually here. So we have the IaC, which is what I showed you, is that actual resource group, and including the role assignment, which is part of that experience with pull requests. But then the actual templates or template specs. One example I have here. which is not the one. This is the one. So if you want to learn more about template specs, then there is a great article how you can deploy a template spec as a link template. So this is a workflow that Megan was using. She created the main template, and she referred to those template specs in her code as a deployment resource. I showed you this about policies, but this one is about create and deploy template specs from the central cloud team side. And obviously, this is not just for them. You can create the library of reusable templates as artifacts as a developer or dev team, and you can host it in your own subscription. So this is just a scenario, right? It's not really that it must be used like that. So you should know that at the moment, in order to actually deploy those template specs, you have two options. Either you produce that template spec as a regular ARM template. So I have it in my, not this one. I have it in my repo as this regular storage account template. Let me just show you the. So it's very similar to what you saw in Megan's workflow. I have some variables to define some unique storage account name, and making sure that it's less than 24 characters, and it's also lowercase. So these are like a good examples of ARM functions that you can use and combine. But it's a regular storage accounts resource, so there is nothing special about that. But if you want to deploy this one, you need to either use Azure CLI or PowerShell. And for those, you actually need, for CLIs, it's actually using AZTS, which is a new command. For PowerShell, it's actually using a new set of commandlets. But in this private preview, in order to make those available, you need to get them from a private repo on GitHub, install them, and run them in some kind of separate session, so it doesn't interfere with your regular AZ PowerShell module, for instance. So that's one option. The second option, which is also quite interesting, is that you can use a regular ARM template to. Let me switch to the right one. You can use actually ARM template and then a regular AZ group deploy or a new AZ resource group deployment commandlet. You don't need those special sort of binaries. But then what you need to do, you need to use this like a special setup where you are actually using template specs as a resource, and you're having like a nested template inside. And the special sort of thing is that inside that nested template, you need to have those left brackets doubled. So you need to use it as a escape, as an escape character. So I have it in my case. Sorry. I have it in my case in as an example in the repo as embedded. So you could see the difference when you visit my repo. You see the difference between using it as a regular storage account or as a template spec resource with a nested storage account deployment. And the only reason why I was thinking which one is better, because my ambition actually was to stretch it a bit, and let's say that the mat wanted to use or try out the bicep. This is the new cool thing, and author the template specs as a bicep file, and then compile it, build it using the bicep CLI, and then deploy it. But if I was sort of using the regular storage accounts as a resource in my template, then I would actually need to have in the environment where I will be doing the deployment eventually in GitHub Actions, I would need to have those special AZ module or PowerShell modules. So that's kind of tricky. On the other hand, if I wanted to use that like a nested option with ARM templates, Bicep doesn't support it at the moment. So it was more like, what would I do? So I can show you what I started doing and playing with it. I thought I would create a custom action, GitHub action, where I would simply have a Docker file that I built from the Ubuntu distro as a base, and I added or included all those custom binaries to it. So and then I would have a shell script that would do all the steps, like picking all the files from a specific directory in my repo, doing bicep build, and then taking those artifacts that it generates and pushing them to my Azure subscription as template specs. But this is not really finalized. But I wanted just to talk a bit about the bicep in general. So unlike the template specs, which you need to be allowed to the private preview, otherwise you won't get those binaries, and you won't be able to use it and deploy to your subscription, because your subscription need to be whitelisted. The bicep is actually fully public. Anybody can start playing with it. You just download that binary. It's a single binary. It has a very similar sort of idea like Terraform. It's one exe file, and then you use build, and then you would use a regular AZ CLI to actually deploy the outcome. But what I also found as a very interesting is this website, which is called Bicep Playground. It doesn't have a very a user-friendly URL, but the idea is that you can actually write your Bicep code here, and it would show you how it would look as an ARM template. And obviously, if you do mistakes, it would sort of it will show you that it's there is an error. So you can learn quickly by doing that. So I use that Bicep Playground as a validation that the code I built. So I'm using in template specs, which is this one. No, actually, what I wanted to show you is that I actually have one example of a Bicep file in the repo. If I copy that, which is producing the same template spec Contoso storage account that you saw. So if I paste it to the playground, actually it gives me the exact same ARM template that I actually have in the repo. So this is a good validation that it works. Bicep as in general is really interesting. It's a transpiler. It's a new domain specific language which should allow you to simplify the infrastructure as code that you write. It looks It looks similar to Terraform, if you're familiar with that. And there is a lot of interesting features coming. So they have a public roadmap, if you're interested. Yeah, I need to authenticate. It has a public roadmap. So at the moment, we are coming to 0.2 release. And there are some features coming, like at the moment, the current release doesn't support loops, for instance, which is very important, but the new 0.2 will. And what they have in the backlog is also support for modules, which is essentially like having those very small artifacts with maybe a single resource type, and then you can call them like you have in Terraform or now in template specs. So really, really promising. And if you look at the syntax, it's still a declarative language, but the way you are referencing object and object properties, it's much simpler than here. So just to compare, this bicep file for my storage account has 34 lines of code, and the ARM template has 49. So, but this is a very simple example. It's much more visible when you have a complex file and you compare the length and yeah. So since I was interested in how to automate that, there is a good blog post from Sebastian Groff, I hope I pronounce it correctly, who actually wrote a custom GitHub action to do what I thought, just to build a JSON templates from the bicep file in GitHub Actions. So if you're interested, you can test it out and use it in your GitHub project. Yeah, he's actually using his own IaC login action, and this is a dependency or prerequisite for then using the bicep action as well. So you could try it out. I think I included everything that I wanted to show you. So probably a lot of stuff with GitHub Actions and workflows. So all the code, all the content I was showing today is available on this repo. So you can just use it, explore it, copy with pride. I would be happy for any feedback. I think I'm done for my part. So I will just mute myself.
Okay, thank you, David. Yeah, it was a lot of cool stuff. Very nice demo. So I will definitely watch it again after a while because it was a lot of stuff. But I think it's a lot of practical and very useful stuff. So thank you. Yes, and now I will do my part, and I will talk about Farmer. And originally, this idea was that Sven Malvik will do this demo, but unfortunately, he was not able. So, like, he had some changes in his plans, and I decided, since we announced it, so I will do this part. So, will be not as deep as. Sorry, I should switch to demo mode. Not as detailed as probably his, but good enough to get some overview what is Farmer is and how it works. Couple of words about myself. My name is Evgeny. I'm a consultant at a company called Enso, very small but full of professional. My background is developer and architect with more than 20 years of experience. Last 6-7 years, I start focusing on infrastructure and particularly on Azure. This year I got MVP status, and I started my user group. And basically, I love infrastructure, I love automation, and I love share my knowledge and experience. Before we talk about Farmer, so let's do some kind of a recap about what kind of infrastructure as code tools available on Azure today. So we have a lot, actually. We have IaC CLI, we have PowerShell, we have Terraform, we have Azure SDK with different languages. We have ARM templates. Now, recently, we have Farmer, we have Bicep, and we have Pulumi. So, and let's try to group them into categories. So on one side, we have SDK and scripting. And so here we have IaC CLI, we have PowerShell and different SDKs. And the typical challenges that we have with this approach is that it's imperative. That means that you need to implement step by step how you provision your infrastructure. So, and it immediately comes with a complexity because you now need to define kind of the state. So you need to define all dependencies, and you need to implement some checks that, for example, if this resource already exists, then I update. If it doesn't exist, I can create. So, and this complexity grows really quickly. So the script become really big and complex. And also you need to come up with very clear strategy how you handle the failures. So if, for example, if you fail in the middle of the script, what do you do? So you roll back, or you just ignore and continue. So it's a lot of complexity. On the other side, we have tools that work as a desired state configuration, which basically means that you have your current state and you have your target states. You define your state with language that those tools provides, and then this tool is responsible to converting your current state into desired state that you're configuring with your tools. And basically, ARM templates, Terraform, and Pulumi, those three are working with as a desired state configuration tools. Yesterday, I'm actually a consultant, and I'm working in VIPS now. So VIPS, this is a #1 payment solution in Norway, and like 100% on Azure. And we have different teams in VIPS. And yesterday we had a retrospective where every team represented how they work with infrastructure. And the interesting point is that every team has exactly the same starting point. So they start with ARM templates. So they start with ARM templates, and then eventually they understand that it's really hard. So they say, okay, I can't work with ARM. ARM is really hard to work with. And then they do a switch to most likely in IaC CLI or sometimes PowerShell. And then they do start implementing the scripts, and they happy in a while, but then eventually they reach the point that it doesn't work because it's really hard to maintain this script. And then what happened is that a lot of teams, they end up in creating some tools or frameworks that help them to generate ARM templates. Because ARM template as a concept and as a way how to provision and describe your infrastructure works really great. So if you have ARM template, so then everything is fine, and Azure Resource Manager will make sure that your resources are deployed, provisioned, and all dependencies are in place. But again, creating these ARM templates is hard, and a lot of teams implement some tools and framework with different languages like F#, C#, Python, and they also implement some sort of abstractions on the configuration level that, okay, here is my infrastructure, like tool, please generate ARM template, and then they provision infrastructure with ARM template. And some of the teams, they actually go even deeper, and they start implementing provisioning by using ARM REST API calls. So, and some of the teams end up on Terraform, and recently we're evaluating Pulumi. So those three stories. And the question is, why those teams always kind of go away from ARM template. So, and the main reason is authoring. So it's really like the implementation and maintenance costs working with ARM templates really high, because it's really, really hard to work with. It doesn't have a concept like a conditional thing or loops or those kind of concept that you have in regular languages. And of course, it's JSON, so you're not allowed to have any comments, or you technically can, but then you need to do some special tricks. So, and the JSON is really noisy language, so you have a lot of code to maintain. But at least recently, Visual Studio Code extensions for ARM templates are really good. So, like these things getting better, but still ARM template as ARM template is really hard to work with. So, and therefore, ARM template, ARM team itself started to look into some DSL language that will help you work with ARM templates. So you will use some like abstracted language, DSL language, much more simpler than JSON, and then those tools will create ARM templates. So, and currently in the market, there are two tools. It's Azure Bicep and Farmer. And I never heard about Farmer, and the first time I heard about Farmer was actually when Azure Bicep was announced. So the team, Azure Bicep team, they pointed out that Farmer is also similar tool that you can look at, and that's what we basically did. And as I said, also homegrown tools that help you to transform whatever you have into ARM templates. So now let's look at what Farmer is. And the Farmer is a library that helps you safely author ARM template quickly and easily. That's pretty much what it is. And it's written on F#. So, and this is the DSL tool. So, and it helps you write your, like describe your infrastructure and deploy this infrastructure. That's optionally, but you can deploy with Farmer as well. So, and here is an example of Farmer code that provision web application and storage account. So, and as you can see, like those two resources with Farmer, it takes 23 lines of code, and the ARM template result will be more than 100 line of code. So now let's do some demo. So yeah, make Farmer. And since this is .NET, so you can download Farmer template. And then you can just create new Farmer project. And now let's go to Visual Studio Code. Okay, so here is the typical Farmer program. Remove some comments, don't need them. So, for example, if I compile this program now, and run, so what it will do, it will basically create output JSON file that will contain the ARM template. So, and since this is like we didn't specify any resources, this is empty ARM template, and I have a ARM template outline plugin. So here I can see so what actually resources are included in this ARM template. So how do I define resources? So for example, I can let's say I want to create a Azure function. So then I can do let func equals functions. Okay. And the name, the function will be my function. Now, if I run this program again, nothing can happen because I forgot to add it to the ARM template. So I needed add resource. Run. Okay. So now, if you look at the ARM template, we have actually 4 resources. We have server farm, which is a service plan, function itself, storage account, and application inside. So, and that's pretty much what Farmer does. So you can you describe your resources with a F# language, and then Farmer will generate ARM template for you. So let's say if I don't want to, so basically Farmer also uses the convention over configuration. So it defaults a lot of things for you. So for example here, so if I decided to call my function myfunc, then it will automatically create service plan with -farm, storage account with storage, and application inside with also some name. So if you're, for example, not if you don't like this naming convention, you can always use your own convention. So for example, I can say that I want to create a storage account myself. Account, and call it name infrastructure as code farmer storage account, for example. So, and then what I can do, I can tell that, okay, for this function, I want to use link to storage account and add this name of the storage account on it. So, and we don't have this storage account here because I again forgot to add it as a resource. Add resource storage account. Run. Okay, so on here we can see that now the storage account name is IaC farmer storage account. And yes, so and also farmer has a concept of a builder, so we'll cover them later on the presentation. But like it's a lot of conventions. So for example, you know that for your function you need to have a server farm, and then you need to have application inside and storage account, and then you know what kind of dependency between those resources are, and so this complexity is hidden here, right? So now, yes, and basically, if you want to see how many resources currently supported by Farmer, so they have it on documentation, and they like this is open source product, right? So and you, for example, if you don't find resource that you need, you can basically go and implement it. But for now, it's yeah, quite a lot of resources. Like you can implement AKS cluster, you can application inside, then a zones function. But at the same time, so for example, when we evaluated this product in VIPs, so it doesn't go for us because we need API management, we need app gateways, front doors, Terraforms, traffic managers, and they are not here. And for now, at least, we decided to not use it. But for simple projects, this is something definitely to look at. So now let's get back to slides. So, and architecture-wise, Farmer has like one extra abstraction. They call it builders, and function. That's a good example to define what builders is. So, builders is you define what resources you need if you want to provision this particular resource. So, and function, that's an example. You need a farm, you need storage account, you need a function itself, and most likely you need application inside. And also the farmer makes sure that if you use application inside, then it automatically adds application inside key into function settings, and same for storage account. And then what's going on in memory, it collects these resources and transforms them into ARM template. And then you have basically two options. You can either dump it to the file, or you can tell farmer that, okay, I want to deploy this thing into like specified resource group. And then when it comes to deployment strategy, so what are the options available? And basically it's two options. Option number one is that you can say, like, I don't care about ARM template. I just want to provision my stuff. So, and then the kind of scenario would be that you define your infrastructure as a farmer project, and then you use CI/CD tools of your choice, for example, Azure DevOps or GitHub Actions, and then you basically need to either configure service principal and then do .NET Run, and it will provision everything, or you can use AZ CLI command and then connect service principal to this task, and then it will make sure that the service principal has enough permissions to provision resources into specified resource group. Option number two is that, let's say, if you already have infrastructure that is running and you already have a deployment strategy that you use for your ARM templates, then you can use this farmer as a kind of CI step that you generate ARM templates, you upload them somewhere, either, for example, artifact on Azure DevOps, or you can use like storage account. You can do it differently, and then you use like release as a way to download these artifacts and deploy them to Azure. So, and farmer is written on F#, and for example, I never worked with F#, but at the same time, so F# is just another language in .NET ecosystem. So that means that you can use, for example, C# also for some other tasks, and so for like if you need to implement some complicated business logic or some whatever you need to implement, you can use C# as well. And just to demonstrate it, so I decided to implement same function with the farmer, but also use naming convention class, which I write in C#. So because normally when you work with infrastructure, you should have some naming convention, or like convention how you name your resources. So, and in this example, we have a naming convention class that has several functions that get resource group name, and get storage account name, get function name, and get whatever resource name. So in here I can define, okay, in my infrastructure, that's the way how I want to name the resources. So I always should have some sort of prefix in the start, then environment where I deploy, then maybe name of the or type of the resource, or some placeholder for this resource specific configuration, and then postfix that telling whether this is a resource group or storage account. So this is C#, right? So in addition to that, I can also write a test that can validate that I follow my naming convention. So, and for example, if I do some changes in the infrastructure code later, I should have part of my CI pipeline the validation that I follow all my naming convention. So, and then, because again, this is a C# and F#, they can be referred from each other. So I can use this C# class and actually use this to name all my resources. So, and in this example, storage account name I'm getting from this naming convention class. Same for functions, service plan name, and also the resource group name should be calculated. Another thing you can do is, again, this is just a .NET code, you can introduce some way to parameterize your input. So for example, if I want to deploy the same infrastructure into different environments, then I need to find a way how to tell the executable that, okay, I want to generate or deploy resources for lab, prod, or disaster recovery environment. So, and again, you can do it in multiple ways. So you can use it as a parameter, you can define it as a environment variable, or you can use, for example, configuration file for multiple environments. This is .NET ecosystem, and you can find the way that fits best for your needs. So for this particular example, I decided that I will introduce another parameter, input parameter, that will be environment. So that means that if I want to deploy to lab, I will do .NET run and then lab, and then this code will generate ARM templates, storage account function, and then it will deploy. So, and deployment, like syntax, is pretty much same as generate. So you use this deployment object and you tell, okay, deploy, try to execute, and you specify resource group name. And you don't need parameters. So, and then it kind of parses the output, and whether this is successful, it says so, and if it's an error, it will tell you what was wrong. So, and in addition to that, I also wrote some sort of deployment script. So, and this script called publish.sh, because let's say I use Linux or Ubuntu as a agent on Azure DevOps, and I want to run this deployment in Azure DevOps pipeline. So, and then, like, I introduce this script. Here it's a very simple script. In reality, you may have some extra logic in this script, but the kind of main goal for this script is that I can deploy from my machine, and then I use the same script on my Azure CI/CD pipelines. So, and these things are committed to project on my Azure DevOps, so Farmer POC, and then I have a code here. So it's basically those projects that I showed you. And then I also added pipelines, release pipeline. So in the release pipeline, I defined as I decided to use Classic because it's easy to kind of explain and navigate, but you can use YAML-based multi-stage pipeline. So, but for this particular case, I decided to use Classic. So basically, this pipeline has a reference to repository, so where the source code is, and then I define where do I want to deploy my my infrastructure. So, and I have lab, and then I have production and disaster recovery. So, and if I go to code and see what it does, so it basically does nothing. So it has a Azure CLI task that executes my script, publish sh script, with a parameter environment, which is defined here as lab, prod, disaster recovery for different scopes, lab, prod, and disaster recovery. So it also configured that it's automatically triggered if I have any commit to master branch, and it will immediately deploy it to the lab environment. So, and so I already deployed it into IaC Lab resource group. So it has 3 resources. And now what I want to show is, let's say I want to add some tags to my function. So, and then basically what I do, I go to code, I do add tags. Or in this case, it will be one tag. And let's say I want to add the owner as a tag for my resource, and it will be team platform. So then I git add git commit add tags, git push. Go to resources. So, and the new release automatically started, and it is now deploying to the lab. If you go to logs, yeah, and I probably was a bit too quick on the publish. So publish script basically does .NET run environment in infra folder. So it basically will build and run the file. So now it's started deployment. So if I go to resource group and deployments, so now you see we had a new deployment. And actually, nice thing about Farmer, because it operates with the ARM template, you like automatically have your audit log of what's going on your resource group. But also you should be aware that there is a limitation of 800 deployments per resource group. And it sounds a lot, but in reality, it's very easy to reach this point. And then what will happen is that if you have 800 deployments in your resource group, and you want to deploy something, it will fail, and you will not be able to deploy. And then you need to remove actually some deployments in order to deploy again. So, but this deployment was successful. We can always see what was deployed. So we have this template that Farmer generated and deployed. And if you go to function itself, don't have tags. Interesting. There. Function. Am I on the right project? Yes, it is. Let me check template. Uh-huh. Yeah. So, but I don't think I will kind of fix it now. So the idea is that, so my point was here is that even though if it's this is F#, so it doesn't stop you to use C# as for example, if you used to work with C#. So, and it's because this is .NET ecosystem, so you can do a lot of stuff. You can do a lot of conditional things. So because, for example, if you have a disaster recovery, like production and disaster recovery and some other environments, and you have some differentiations between those environments, so it's much more easy to implement those conditional things, languages, F# or C# compared to, for example, in ARM template itself. So, and also you can implement a lot of testing. So you can have testing that will test whether kind of naming convention or the business logic that you use in your system. And yes, so, and basically very nice tool, Farmer. I highly recommend you to have a look, especially if you have relatively small projects. I think it fits really well. Or if you want to learn, for example, how to work with ARM templates, I think it's a very good way to actually generate ARM templates. As I said, so they don't support all resources, but they constantly releasing new function, and it's open source, so that means that you can contribute and implement your own languages. So that was my part. So if you have any questions, please send them on the comments or inside our meetup group.
Yeah, I was monitoring the chat on YouTube, and there was a few questions about Bicep. There is a new question, maybe to you, about any tips on automatically cleaning all deployments from resource groups. So
Yes.
One thing is that the Azure Resource Manager roadmap for 2020 plus has one of the point is actually to remove that limit of 800 deployments in any resource group, which is maybe a long-term goal. There was also an option for introducing like an auto cleanup. So you would get the oldest deployments, like the first, and yeah. So it will be like rewriting those as an option, but I don't think this is in place yet. Do you have any comments to that?
Yeah, so I can tell that it can be even more complicated because, let's say, especially in the production, so most likely you will have some delete log. And that means that you, like, in order to remove this deployment from resource group, you actually need to remove this log first and then set it back. And let's say if you want to automate it, then the service principal that will run this runbook or whatever, like automation pipeline or script that you use, should have actually quite heavy permissions in order to remove this log. So it's we thought to automate it in VIPs, but we immediately reached the point that it's not that easy. So, and for now, we just first of all, we stopped using our ARM templates that heavily in that place where it was failing before. That was API management. So, but we constantly monitoring like the limits and do manual cleanup basically now. That's how we do it in VIPs.
Yeah. Apart from that, there was not that many questions. Maybe as a comment to, there is a perception that ARM.json doesn't allow for many things, including comments, which is actually not correct. You can have both single line or multi-line comments in ARM.json, and even the VS Code extension will recognize it as a comment. A regular JSON probably would. The linter will probably complain about it, but ARM.json does support it, so you can really do that. There is also like a if function. You can use loops using copy function, and you can use conditional deployments. Yeah, so there is a I don't know how many functions are available in ARM.json language, but you should check them out. And there are functions for working with strings, with like a logical functions, with integers, working with resources. So I think it's really much more than just JSON. But yeah, I agree that there are always some limits.
Yeah, I totally agree. I personally like ARM template, and I'm most likely the only person in VIPs who can do it. But and I know it's a lot of things you can do, because it's a lot of techniques you can use to, for example, implement like parameters that contain more or less like the full like resource. But you need to know those things, and they're not really well documented, and they have like some edge cases. So, and that's what I meant, that ARM template has some costs. like initial implementation and maintenance. But when you have ARM template, then you are basically totally fine. And performance-wise, so if you have a lot of resources with a lot of dependencies, if you give this specification as ARM template to ARM template manager, so then it will guarantee that it will deploy it the fastest possible way, because it knows all the dependency and it will run things in parallel. So it's also, if you have a big infrastructure, ARM template will maybe be the fastest way to provision. I'm not kind of comparing with Pulumi and Terraform because they do things differently, but yes. So I personally like ARM template, and I think this is and especially now with Bicep supported by Microsoft itself, I think that the kind of authoring experience will be much better, and I'm looking forward when it will be on general availability to start actually recommending it for the customers.
Yeah. The product group said themselves that 0.3 release would be something they would sort of say it's like a production stable. Now we are on 0.1, so there is a lot of things they really need to add, like those loops and maybe the modules. So you can actually really just have like a modular approach instead of having everything in one big Bicep file, which is not how it works well for ARM.json. Yeah. Haven't heard about roadmap plans for removing the 800 limit. That's good news. Yeah, so I'm referring to a slide that was, I believe it was at Ignite for that. So yeah, that's definitely coming, but there is no ETA for that. Good. No more questions on the chat. Maybe with one from Rickard. There are all of... Yeah, I agree with Rickard that I wouldn't probably do any ARM template authoring without VS Code, to be honest, and those extensions, because they save a lot of effort and headache. So I don't think that support in Visual Studio is that great comparing to VS Code and the extensions that are available and the snippets and everything. So yeah.
Yes.
I think it's time to wrap up.
Yes. So thank you, David, for your presentation. I think I learned a bunch. So and definitely something I will read. And thank you guys who joined us today. If you have any questions or if you have any ideas of what or for example, if you would like us to present something, or if you have some theme that you would like to present, please contact me and we will arrange it. And yes, again, next week, Pulumi implementing infrastructure with Pulumi. And if you, for example, didn't attend the previous one, then I highly recommend you to go through the labs from the first one before you join the meetup that we're gonna have next week. So, and other than that, thank you, and hope to see you next time. Thank you. Bye.
Bye-bye. Thank you.